Yes. Now we were on the third numerical. A body of mass 120 gram is vertically upwards to reach the height of 5 meter. Calculate work done. We need to calculate the work done, and the given gravity is 10 meter per second square. So here what is given? A body of mass that is given 120 gram, and it is taken vertically upwards, that we are working against the gravity now. So we will take acceleration due to gravity here as negative, that we will take the value as minus 10 meter per second square. And here 120 gram is given, we will convert it into kilogram to make the whole numerical in SI form. So let us proceed with it. So what is given to us here? We are given with the mass, that is M is equal to 120 gram, and we have done the work against the gravity. Okay, so we will take acceleration, and that will be acceleration due to gravity over here, and that will take minus 10 meter per second square, because work is done against the gravity, and it is taken vertically upward, so here minus will come. Fine. So displacement is also given, that is 5 meter. First of all, let us see, we have to make the whole numerical in SI form. Here it is given in meter per second square, it is in SI form, it is in 5 meter, it is in SI form, and we will have to convert this in kilogram. So that will be, we will divide it by 1000, and we will obtain it as in kilograms. And what we will obtain 0.12 kilogram over here. Now simply we are having all the values, and we need to calculate the work done over here. So what is work done? Work done is equal to force into displacement that is W is equal to Fs, and force is what? M into A multiplied by displacement. What is mass over here? That is 0.12, and acceleration we will take here as acceleration due to gravity, and that will be minus of 10, and displacement is given to us, that is 5. So after multiplying with it, what we will obtain? We will obtain minus 6 joule as our answer. So our answer is minus 6 joules, that we need to do the work of minus 6 joules, and obviously the work done is negative over here. So thank you. Now our fourth numerical is, a body of mass 15 kilogram undergoes downward displacement of 40 meter under the effect of gravitational force, and we need to calculate the work done over here. That body of how much kgs? That is 15 kgs, and that is displaced downward due to the gravitational force. Okay, so how much it is displaced? It is displaced 40 meter, and how much the mass that a body has? That is 15 gram. And now we need to calculate the work done over here. So let us proceed with it. So what is provided to us? One thing, we are working because of gravity, and we will take acceleration as acceleration due to gravity, and it is in the downward direction, and obviously we will take as positive 10 meter per second square here. Mass that was provided to us was 15 kilogram, and displacement is of 40 meter. And we need to calculate the work done over here. Simple it is their simple formula. We will use force into work is equal to force into displacement. And what is force? Mass into acceleration. We will take acceleration due to gravity here, and displacement will be s. So what is mass here? 15, and acceleration due to gravity will be 10. And how much it is displaced? It is displaced 40 meters. So overall we will get the answer as 6000 joules. 4, 5, 4, 15, 60. Yes, 6000 joules as an answer over here. So work done is positive over here, and the work done by us will be 6000 joules. Thank you. Now we will proceed with the next lecture, and till now we have done what is work, what is positive work, negative work, zero work, and some numericals based on work. And now we will proceed with the next topic, that is energy. Let us start. Now what is energy? Energy is capability to do work, capacity to do any kind of work. Suppose I need to throw a ball, and obviously I have to use my energy over it. I have to use my strength, and if I'm capable to throw that ball, means I have that much energy to throw that ball. Right? So what I will do, that I will lose some energy and that ball will be thrown. Obviously that ball will gain some energy. Fine with it. So obviously capacity to do work, capacity of doing work is energy. An object which does work loses energy. An object on which work is done, that will gain energy. And SI unit is obviously, that is also joule. 1 joule energy is required to do 1 joule of work. That if it means that if we require to do 1 joule of work, at least 1 joule of energy is required to do that work. 1 kilojoule, obviously from kilo we come to know 1000, and 1 kilojoule is equivalent to 1000 joule over here. Thank you. Now let us proceed with the different forms of energy, and I want to start with kinetic energy. Let us start. Energy possessed by the body by the virtue of its motion. When the object is in motion, that object will have kinetic energy. It's because of its motion. It is a scalar energy. It is scalar energy means it has magnitude over it rather than direction. Its SI unit is joule. Obviously it is a form of energy, and its SI unit will be joule. And mathematical expression is half mv square. So we can also write in this form Ek, or we can take it as K dot E. That is kinetic energy, and that will be half mv square. So any kind of energy that is possessed by the body because of its motion, by the virtue of its motion, is kinetic energy. Let us proceed with more about it. Thank you. Now we will do some examples of kinetic energy. First is a falling coconut, a rolling stone, a flying aircraft, a flowing water, a blowing wind, a running athlete. Obviously. So in all these examples, so let us start with one by one, okay then. That a falling coconut, obviously a coconut is falling from the tree, and obviously that coconut will be in motion. So obviously which energy it will be having, that will be kinetic energy because of its motion, because it is falling from the tree. Rolling stone, if you are rolling a stone by your leg, okay, by your foot, and obviously that stone will gain some energy, that stone will come in motion, and that will gain kinetic energy into it, because that stone will roll and that will be in motion. A flying aircraft, obviously an aircraft is flying in the sky, it is moving in the sky, and obviously it is in motion, that it possesses kinetic energy. Flowing water, yes, water is flowing, it is moving, so it is in motion. Obviously it is also containing kinetic energy. Blowing wind is blowing wind, it is also in motion, will be having kinetic energy. Running athlete, if the athlete is running, it's moving, it's in motion. So obviously in all these examples, all the objects possess kinetic energy. Now, the faster the object moves, the more work it does. Means how much fastly any kind of object will move, how much force it will possess, how much displacement it will possess. Obviously, that much work will be done. So, how much faster the object will move, that much work will be also done. Thank you. Now our next topic is expression of kinetic energy. We will derive the value of the kinetic energy by taking one example. Let us take, that is, consider the body of mass m. We need to consider the body of mass m, and that is in kilogram, that is moving with velocity v, and that we are taking in meter per second. Then the work done, how much we will do that work, that will be equivalent to the kinetic energy of that body. So let us derive about it. Now everybody know that work is force into displacement. Work is what? Force into displacement, and we also know what is force, that is mass into acceleration. We will submit the value of force over here, that we will get mass into acceleration into displacement, and that is what? Work done. Now let us consider it as number 1. Now we know about the Newton's that third equation of motion, that is v square is equal to u square plus 2as. We will take the value of s from here and we'll sum it over here. But we should also know the value of v square and u square over here. Now what we are considering over here, that a body of that any mass m is moving with the velocity v. It's obviously moving, it has started moving. Obviously we will take initial velocity as 0, because its initial velocity will be 0 over here, because its starting point its velocity was 0. So we will put the value, that will be 0 over here, plus 2as. We will calculate v square upon 2a as the value of s over here. Fine with it. Now what we will obtain, we will substitute this value, put the value of 2 in 1. What we will obtain, work done will be equal to mass into acceleration into v square upon 2a, and that will be mv square upon 2. And obviously this is equal to kinetic energy of the object, and that is what? Half mv square. So this is only the derivation of kinetic energy. So we can express the expression of kinetic energy in this form. We can derive the expression of kinetic energy half mv square by taking this example. Thank you.